that get the volume and put it in the calculated volume and put it in the 1000 ml volumetric flask, and then top it up with water. By so doing, you prepare 1 molar HCl. All right. Now, assume that you are provided with a mixture of benzoic acid and phenanthrene neutral. Hence, in not more than 10 lines, provide a method that can enable you separate the mixture and recover its components. Now, in not more than 10 lines, so we are to give at least 10 steps. So, what are the 10 steps that will be needed for this experiment? Because they say no more than 10 lines. I would love to put it in form of steps. Now, 1, you are now going to write get an appropriate solvent that is soluble in benzoic acid but sparingly soluble in phenanthrene. Get an appropriate solvent soluble in benzoic acid but sparingly soluble in phenanthrene. Are you getting it now? Now, have you gotten that solvent? Now, what you are going to do is get a separating funnel and put in the mixture of benzoic acid, phenanthrene, and the solvent. The mixture of benzoic acid and phenanthrene and the appropriate solvent. Get a separating funnel and put in the mixture and solvent. Then shake together. And determine separation. There will be 2 layers. One will be a layer containing benzoic acid and the other one will be a layer containing phenanthrene. It's more like solvent extraction using separating funnel. One will be a layer containing benzoic acid and the other will be a layer containing phenanthrene. Is that okay? Now, have you gotten that? The next thing is to now decant in the sense that you should get the layer containing the benzoic acid and then get the layer containing phenanthrene. Are you getting it now? Remember that the benzoic acid is soluble in an organic solvent. Now, after you decant, evaporate the solvent. Evaporate the solvent, the organic solvent. Now, after evaporating the organic solvent, so you are now going to get the benzoic acid. Are you getting it? Only, and then the phenanthrene. Now, these ones you can actually precipitate them. Precipitate benzoic acid and phenanthrene using ice. Then after precipitation, you can now use the suction pump to actually remove the solvent, which you are going to write number 7. Use the suction pump to remove the solvent and then dry at appropriate temperature to avoid the loss of thermolabile constituents. Alright, that is how you can actually separate them. You can use solvent extraction. That is just the method I've explained here. Is that okay? That is that. Now the next one, how will you confirm the identity of the recovered component? You can confirm the identity of the recovered component by using a mix by using hyphenated techniques. Now these hyphenated techniques include you can use chromatography coupled with UV. Chromatography also coupled with IR. That is the hyphenated techniques we are talking about. Chromatography coupled with mass spec. Chromatography coupled with NMR. Alright? All these ones will actually help you to identify the organic compound by the use of hyphenated techniques. So chromatography coupled with UV will help to tell the degree of unsaturation of the organic compound. IR will tell us the different functional groups that are present. Mass spec will tell us the fragmentation pattern and the presence of isotope if present. And NMR will tell us about the environment of the proton, which is proton NMR, HNMR, and they will also tell us the nature of carbon present, which is also called carbon NMR or carbon 13 NMR. So all these methods can be used to identify the confirm the identity of the recovered product. Now the next question is, what is diazotization? Diazotization is a method. This is a method, or just right, this is a method of converting aromatic amine, alright, into their diazonium salts. By reaction with sodium nitrite and HCl. By reaction with sodium nitrite and what? HCl. That is what diazotization is all about. You need to give us something like this. Alright, you can decide to say this place is COOH. You can just decide to say something like that. That is it. So diazotization is a process of conversion of primary amine to the diazonium salt by the use of sodium nitrite and HCl and sodium nitrite. Sometimes you also have HNO3 added, which is nitric acid, added to the reaction mixture. Now this is going to form the diazonium salt. Of course, you can actually see it here. The diazo. This diazo. So this is aminobenzoic acid, and this is 2-azobenzoic acid. Because they might ask you to name the product. Alright? So that is that for this question. The next. Okay, we've answered it. Now, what is the missing reagent? Name a molecular formula in the reaction below. Think the reaction they are asking. I think we jump to one question. Okay, we not write this question. Describe how you prepare or resolve a mixture containing benzoic acid at 50% naphthalene. Now, it's the same process that I stated here. That's what you will use for this particular one. Alright? Describe how you resolve the same process. Alright? Then we have the next one, which is something like this. Exactly what I stated than the other time. We have sodium nitrite, HCl, what is the name of this product? This one is 2-amino benzoic acid. This is sodium nitrite, not nitrate. This is hydrochloric acid. Now name the reactant and the product. I've given you the name of the reactant as 2-amino benzoic acid, and the name of the product is 2-azo benzoic acid. This group here is an azo group. All right, or we can say 2-diazine benzoic acid, but I'll actually go with 2-azo benzoic acid. Oh, are you getting it now? All right. What is the formula for the factor? Factor is equals to weight of standard sample all over milli equivalent times titer value. Weight of standard sample all over milli equivalent times standard sample. All right, that is the formula for factor. You know what the milli equivalent is, then you know what the titer value in mil. Why is it necessary to obtain a factor of a solution? Now, the factor of a solution is used as a correctional measure. Is used as a correctional measure for standardization of reagents whose concentration are questionable but to be used for standardization of other material. You want to use something for standardization of other material, but even that thing itself, let's say you have 3 things, A, B, C. You want to use this B to get C, but even B self, we are not sure of who B is. You must get the identity of B to get C. Are you getting it now? So what we now do is that we use this A. We know the concentration of A very well. We use A to get the exact amount of B. Are you getting it? Then that of B now is now what we are now going to use to get that of what? C. B is unknown, but you want to use B. A and C cannot react, but B and C can react. You want to use B to get C, but you don't even know the concentration of B. But you can get the concentration of B from A. So first of all, use A to get B, then use B to get C. That correction that A, when A and B react, whatever you get that will correct the exact concentration of B, or that will make to give you the exact concentration of B, is what we call the factor. All right, so that is that. Now, this one, there are questions that we forecast. All right. All right. We have the next question here that says, write the reaction for the conversion of benzophenone to benzhydrol. Now, we want to write the reaction for the conversion of benzophenone to benzhydrol. Now, the first thing you need to understand is What is benzophenone? Now, benzophenone is when you have more like acetophenone, but this time what you have is benzene ring. So this is benzophenone. All right. Now, this is a ketone. So what's the name of this ketone? We said it is benzophenone. Now, this benzophenone, if we react it with sodium hydroxide and ethanol, this is going to give us benzhydrone, which is something like this. It's a reduction reaction. So here we're going to give us OH, of course with H, which is benzhydrol. All right. Now, what is another name, or what is another name for benzhydrol? Another name for benzhydrol is diphenylmethanol. So you can write it down. Diphenylmethanol. This is an alcohol functional group. You can see benzhydrol is alcohol functional group, while this one is a ketone functional group. How are ketones converted to alcohol? I believe every one of us know how ketones are converted to alcohol in this class. Ketones are converted to alcohol by reduction. When this is reduced, this carbonyl group is reduced, it's going to give us the alcohol functional group. All right. So the name of this reaction is a reduction reaction. All right. Now, what are the reagents used for this conversion purpose? Stated some of them here. You have zinc, sodium hydroxide, ethanol. All right. You also have zinc, sodium hydroxide, ethanol. Okay. You also have other one like sodium amalgam, which is sodium and mercury. All right. You also have generally these are the reagents that are used for the conversion. All right. Now, other compounds that can also be used are lithium aluminum hydride. These are strong reduction agents. Then we also have sodium borohydride. These ones, they are strong conversion agents. However, sodium borohydride is not used for carboxylic acid. You don't use sodium borohydride for carboxylic acid, but you can actually use this lithium aluminum hydride for carboxylic acid. So all those ones, they can also be used as reagent for the reduction. All right. So this can be used as reagent for the reduction of this. Is that okay? So that is that. Write the mechanism for the synthesis of methyl orange. Now, like I said, that the synthesis of methyl orange is diazotization. It's a diazotization reaction. Diazotization reaction. Now, how is the diazotization reaction like? You start it with sulfonilic acid. All right. Sulfonilic acid is something like this. Of course. All right. Now, when this sulfonilic acid undergo reaction with acid-base reaction with sodium triazocarbonate. Sodium triazocarbonate is a base. This functional group here is an acid. So there could be acid-base reaction. where this hydrogen will be given off by the acid and the sodium will attach itself. So this is going to give us a product which will be like this. So we have NH2 and then you have SO3 Na. Are you getting it now? This product is called 2-amino benzene sodium sulfonate. I mean, not 2-amino, 4-amino benzene sodium sulfonate. Are you getting it now? Now, when this reagent is now treated with sodium nitrite and HCl, is now going to convert this to something like this. You are going to have something like this. Sorry for the way I drew it. SO3Na. Here will be positively charged. Of course, the chlorine will still be here, which will later be given off. Alright? So this is going to give us something like this. Now, this one now, which we call 4-azo. Are you getting it? Or you can say 4-diazo or 4-azo. This is an azo group. 4-azo benzene sodium sulfonate. Why is it 4-azo? This is 1, 2, 3, 4. The azo group is at position number 4. So you say 4-azo benzene, then this sodium sulfonate. Now this reagent is now what we now react with NN-dimethyl aniline. So NN-dimethyl aniline is something like this. So what I'm going to do now, I'm going to write how these reagents will react. So we have NN-dimethyl aniline, which is something like this. This is the structure of NN-dimethyl aniline. Now this NN-dimethyl aniline is going to react with this compound here, which is azo-benzo sodium sulfonate. Alright, now what do you think will react in this compound? This group here is capable of coming here, and then this one here will come up. Now at the end of the day, they will amend themselves again. We'll now have 3. The chain of reaction is more than what we are actually seeing here. Alright, but at the end of the day, what we are going to have would be, at the end of the day, what we are going to have will be something different. I mean, this ring here will still be present. It's more like aromatic substitution reaction. Here this one will substitute one hydrogen and then attach itself. Alright, but we don't want to go into those very long mechanisms. So this is going to give us CH3 and CH3, and then here will be something like this. Here will be N double bond, here will be N, alright. So that is the mechanism for this reaction. Now, but as this thing is like this, it is not that stable. This color here is yellow. It is in the neutral form. So that is why we said that methyl orange in the neutral form or in alkaline medium is yellow. Alright, if you pass this through an acid, it's now going to convert this. The acid, what the acid will do is that there's something that will actually happen here. This group here has the tendency to mobilize to this place, why this one will move here, why this one will move here. What I mean is that when you put this in an acid medium, this group here will come here. Are you getting it? Now, when this group comes here, what do you think will happen? Are you sure it is at that position? Yes. That group there will come there. And then this one here will come up. Yeah. Is that okay? And then finally, this group here will come here. So that at the end of the day, you are going to be having something like this, which will now show you the red coloration. CH3 and CH3 here will be positively charged because of the presence of an extra this thing here. And then you have this benzene ring. Now for the benzene ring, the bonds will only be here. Here will also be double bond, N, and then this will be red color. So this is the form of methyl red in acidic medium. So this form here is in acidic medium. It will be red. Why this form here is in neutral or basic medium, which is yellow. So this is a potential question when they ask, what is the color of methyl orange in acidic media? What is the color of methyl orange in basic media? Alright. What is the color of methyl orange in acidic media? I've told you that in acidic media, methyl orange is red. In basic media and neutral medium, it is yellow. 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 Alright. What kind of reaction is this? It's supposed to be what kind? I told you that this is diazotization reaction. Diazotization reaction. Now, what was the starting material for this reaction? We use sulfonylate acid and NN-dimethyl-aniline. This reagent here is called NN-dimethyl-alanine or aniline. Alright? Exactly. Now, what is IRO? What is the use of IRO spectroscopy? We said IRO spectroscopy is used to determine the various functional groups that are present in a compound by means of vibrational frequency. What is the range of wavelength for functional group region? Now, the functional group region is within 4,000 centimeter reciprocal to 1,500 centimeter reciprocal. While for the fingerprint region is between 1,500 centimeter reciprocal to 400 centimeter reciprocal. Alright, you should be able to interpret the IRO graph. I believe everybody know how the IRO graph is. Something like this, where you may have something like this, and then you have others. I believe everybody know how to. I've taught how to interpret IRO graph before. Check some of our videos. I believe that is the end of some of the questions we should be expecting from the practical. If there are others, I'll still let you know before the exams. Thank you very much for your time. Bye bye.